Hello everyone, I'm Sabir. So today we are going to solve this problem, find if path exists in graph. So what is given in the question is like there are n vertices and each vertex is labeled from 0 to n minus 1, and this graph is given in the form of edge list, and edge list means like for each particular edge they will be giving two vertices in between which the edge exists. Okay, and what they have asked in the question is like there will be one source and there will be one destination, and we need to check if the path exists between source and destination. So over here, let's say this is the edge list, okay, which will form this particular graph, and they are asking if the path exists between 0 and 2 or 2 or not. Okay, so here the path exists, so will be returning true. And in for this graph they have asked if the path exists between 0 or 5 or not. So 0 is over here and 5 is over here, so it is not connected graph, that's why it will return false over here as the path doesn't exist. So yeah, go through the question once, and after that we will discuss on the approaches which we can take over here, and we will decide which approach we need to take, and after that we will discuss the coding solution of it. So I hope you have went through the problem. So we will be discussing two approach for solving this problem. One is easier way and one is the better way. So what we can do over here is first approach will be we can do DFS or BFS, and we will check if particular source is visited in a particular breadth first search iteration and the destination is not visited, then it means like it doesn't have the path between two. Okay, and if both of them is visited in the same breadth DFS or BFS traversal, then it means like there is a path between two. Okay, and how we can do it is like in the given question it has a edge list, and we can convert that edge list to a adjacency list. Okay, so for this particular graph the adjacency list will look like this: 0 will be connected with 1 2, and 1 is connected with 0, and 2 is connected with 0. So the immediate neighbors through which the vertices are connected, that we will be putting in the form of array, and it will be going against that particular vertex. Okay, so similarly this is the adjacency list for this particular graph. Okay, and using this adjacency list we can do the depth first search or breadth first search traversal. Now it will solve this particular question, but there can be a twist in this question. The twist can be like the given source or vertices, instead of source of vertices they can give the list of source and vertices in between which we need to find the path exist or not. Okay, so and that can also go to 10 to power 5 or any number. Okay, so in that case the DFS or BFS traversal will give us the time limit existed error. Okay, TLE error. So to eliminate that, what we can do over here, instead of thinking it in traversal way, what we can do is like for each vertex we can find a particular route. Okay, so and we can indicate that particular set of graph with that particular route. Okay, so what I mean is like for this particular graph we can consider 0 as its route, and for this particular graph we can consider 3 as its route. Okay, so all the vertices will have the root 0, and over here all the vertices will have root 3. Now for given source and destination we will simply check if that particular source and destination have same route or not. If it has same route, then it means the path will exist between that source and destination, and if it not, then the path doesn't exist. Okay, so yeah, so how to find this route and set for all the vertices, that we are going to dive deep in the code, and we will understand how we can do that. Yeah, so over here in the code I have taken I have created one root array. Okay, it will be same size of the number of vertices we have. So and also I have initialized all the vertices over here. Okay, I have initialized all the root of vertices by their vertex name only at initial level, and one by one we will go through each of the edges, okay, over here, and we will check if the root of that particular vertex between the two endpoints of the edges, I have taken it as u and v. Now I will check for if the root of u is same or with root of v or not. Okay, if it is not same, then we need to make that root of u same as root of v, because the edge exists between them. Okay, so let's say this is the edge list. Okay, and graph will be this will be the graph forming over here. Okay, now what I will be doing, like initially 1 and 2 will come, okay, and I have initializes all of their vertex name as their root. Okay, now as 1 and 2 comes, so this will be v and this will be u. The root of u will be set to the root of v. Okay, so now what will be so both 2 and 1 will be pointing to 1 after this iteration. Then 3 and 4 will come. Okay, so after this iteration, the both root will be pointing to 3. Okay, now after this iteration, okay, so so 2 and 3 will come. Now that root of 2 will be 1 and root of 3 will be 3 currently. So after this iteration, the root of 3 will also become 1. Okay, so in this way all the roots will start pointing to a particular number only, the which is one of the vertex in the given set. Okay, yeah, so how we did that is, if root of particular vertex is u is not equal to root of v, I will make the union of these two graph. Okay, so how I did it, I make the root of I will find the root of this particular level. So 2 will be 2's root will come 1, so I find that root over here. Okay, and I will point it to the root of the v, u. Okay, so how this find root works is like it will go over here if the root of v is equal to its vertex itself. Okay, so, which means root of 0 will be pointing to 0 only. Okay, so this is our base condition. In that case we will return 0, otherwise we will try to find the root of that particular element. So what I mean is, let's say 0 1 2, this is the graph. Okay, and let's say 2's root will be pointing to 1 and 1's root will be pointing to 0, and 0's root will pointing to itself only. Okay, so in this case whole graph root will become 0 only. What I am doing, I am trying to find this particular point. Till that point I will make a recursive call. So at first 2 will be pointing to 1, so then I am passing 1 in the next function call. Okay, root of that particular element. Okay, and then root of that particular element will be 0. So next time 0 will be passed over here in the function call. Okay, now while returning the value, okay, while returning the value, I will be pointing to this particular I will be setting again all the root values to that root of whole graph, which means at first if this is the case, then after second iteration this 1 will be pointing to 0, and it will again in the return value it will return 0 over here, then 2 will directly point to 0. Okay, so you can understand, after few iteration each of this point will point to the graph's root. Okay, each vertexes will start pointing to graph roots by making this jump. So after few iteration this will be of O of 1 only, because first time it will if it is different, then in the second iteration it will be directly going to the root value, and root value will it will return the function from here only. Okay, so after few iteration this will become O of 1, and this answer will become O of 1. and yeah, so this will also become O of 1. So this way we can solve it, and if the root of particular source is same as root of destination, then it means the path exists between two. Yeah, so go through this solution once. I will paste it in the GitHub. This is very important method in the graph, and this particular can make a lot of things easier in graph, because here we don't actually have to traverse the graph to find the points whether they're connected or not. Yeah, so this can be used in multiple ways. So one I can think of, like in real world, let's say there is some city California in America and city Surat in India. So if they are connected or not, we can directly answer it if we have saved all the routes. Okay, if we have memorized all the routes using this algorithm, and we can directly check if they are connected or not using this algorithm, instead of traversing all the roads joining California towards India. And we know that it won't exist because there is ocean in between, which means those are two disconnected graphs. Yeah, so without even traversing whole world, we can understand if there is a like if two cities are connected or not. Yeah, so in that sense it is very great, this particular solution. And yeah, so go through this, and if you like this video, then do give it a thumbs up and subscribe to the channel. Okay, thank you, bye bye.